You know that feeling, right? You build something amazing on your workbench, it works perfectly, and then you take it out into the real world and it just completely falls apart. It's a super common story, and today we're going to talk about how to actually bridge that gap, how to take your ideas and turn them into robust, industrial-grade products using Bluetooth Low Energy and the amazing ESP32. So let's just start with that big, frustrating question. You've poured weeks, maybe even months, into a prototype. It works. The demo goes off without a hitch. But the second you try to deploy it in a factory, or out in a field, or maybe a hospital, poof, it just dies. Why on earth does this keep happening? Well, the source material really hits the nail on the head here. That huge gap between a prototype and a real product is where so many great ideas go to die. And the number one reason? It's almost always the wireless communication. Wi-Fi doesn't have the range, cellular gets super expensive when you have lots of devices, and classic Bluetooth, well, it just destroys batteries. It's a total minefield. But there is a solution. And it's one that has quietly been powering a revolution in pretty much everything, from the fitness tracker on your wrist to the heavy-duty sensors in a factory. And that solution is the incredible combination of Bluetooth Low Energy, or BLE, and the ESP32 microcontroller. And what's really mind-blowing is how accessible this technology is. We're talking about a complete computer on a chip, with both Wi-Fi and Bluetooth built right in, for less than $5. I mean, that's less than a cup of coffee. This one tiny component unlocks a whole universe of products that you can actually build and ship. Now, it is absolutely crucial to get this next part. BLE is not the same thing as the Bluetooth you use to stream music to your headphones. Not at all. Think of classic Bluetooth like a big multi-lane highway. It's high speed, it uses a lot of power, and it's built for constantly streaming tons of data. BLE, on the other hand, is more like a quiet bicycle path. It's incredibly efficient, uses almost no energy, and it's perfect for sending these tiny, quick bursts of data, like a single temperature reading. Okay, so to really understand how BLE works, let's use a simple analogy. Every BLE connection has two main roles. First up, you have the peripheral. This is your sensor, your smart lock, your Fitbit. It's the thing that has the data and is basically just shouting out to the world that it exists. The source uses this great analogy. Think of the peripheral as a restaurant with a big sign out front that just says, "Hey, we're open." And if the peripheral is the restaurant, then the central is the customer. This is your smartphone or a tablet or maybe a dedicated gateway. It's constantly scanning the area, looking for those "we're open" signs. And when it finds one it's interested in, it decides to connect to get some data. So the central is simply the customer who sees the sign and decides to walk into the restaurant. So the customer is inside the restaurant. How do they know what to order? This is where the whole system gets really elegant, and the analogy just keeps going. The data on the device is organized just like a restaurant menu. You have something called a service, which is like a section of the menu. Think appetizers or desserts. And within that service, you have a characteristic, which is the actual dish, like temperature reading or battery level. It's just a super logical way to find out what a device can do. Okay, so that's the theory. But how do you go from, just understanding these ideas to actually building something real? Well, the best way is to just do it. So let's walk through a 3-project journey that'll take you from a total beginner to building a system ready for industry. Project 1 starts super simple, just turning a little light on and off from your phone. In this case, your phone is the central, and it writes a command, like a 1 for on or a 0 for off, to a characteristic on the ESP32. This is the absolute foundation for any kind of remote control you can imagine. For Project 2, we flipped the script completely. Instead of your phone sending commands, now the ESP32 is going to push data to your phone. This is done with a special property called Notify. So imagine a sensor reading the temperature every single second. With Notify, it just automatically zaps that new value over to your phone. And just like that, you have a real-time data stream. This is absolutely key for any kind of monitoring. And Project 3 is where it all comes together. This is where we combine everything we've learned to build a real industrial system. You'd have a sensor node on a factory motor, for example, monitoring both temperature and vibration. It's pushing that data to a gateway, and if any of those numbers goes outside a safe range, boom, it triggers an alarm. This is a real-world, scalable solution. Mastering these technical skills isn't just about building a few cool projects. It's about building real products and maybe even real companies. So let's look at the features that make this combo of BLE and the ESP32 so incredibly powerful for creating commercial devices. First, let's talk about power.
This is the secret sauce. In its deep sleep mode, the ESP32 uses a tiny amount of power, just 10 microamps. Now, that's not just some boring technical spec. That is the absolute key that lets you create battery-powered products that you can stick out in the middle of nowhere and just leave them alone for years.
So what does a number like 10 microamps actually mean in the real world? Well, let's put it into perspective. If you optimize your code so the device wakes out, sends a quick reading, and goes right back to sleep, a sensor node can run for over 3 years on a single standard coin cell battery. That is a total game changer for commercial IoT. Look, being a great engineer is all about knowing when to use which tool for the job, and BLE is, without a doubt, the king of short-range, ultra-low-power stuff like wearables or tracking assets in a warehouse. Now, if you need to connect directly to the cloud and you've got a power outlet nearby, yeah, Wi-Fi is great. And for really long-range, remote things like smart farming, LoRa is a fantastic choice. Picking the right tool is honestly half the battle. And once you have these skills, you can start building actual businesses. I mean, think about it. Smart agriculture sensors for farms, asset tracking tags for logistics, low-cost medical wristbands to monitor patients, or that machine health monitor we talked about. These are all multi-billion-dollar markets, and they're all accessible with this exact technology. So we've covered the why, the what, and the how. We've seen the path from a blinking light all the way up to a scalable industrial system. But now the focus really shifts. This becomes about what you are going to do with this new capability. And I want to end on this really powerful quote from the source material. This whole journey isn't just about learning facts. It's about building capability. And that capability is the one thing that separates the engineers who build things that only work on their desk from the engineers who build things that work in the world, who actually ship products.
You now have the fundamental concepts down. The tools are ridiculously cheap and accessible, and the world is just full of problems that are waiting for a smart, connected solution. So the only question left is, what will you build?